In another video previously, we had used calculation as well as measurement to find the midpoint of this line. All right. Now, what we want to do is calculate the length of this line. You could measure it using a ruler going across, but you'd have to do that on your graph paper, right, to see how many centimeters this line, or how many centimeters long this line is. However, we're going to use a calculation here. Let's call A 0.1. So at A, right here, you see the A here, we have our 0.1, x1, y1, x1, y1, which is, it is above x equal 1, so it's 1 comma, and beside 2. So it lines up, this point lines up with x equals 1 and lines up with y equal 2. Good. At B, right here, we have our point 2, x2, y2. So we can see that B lines up vertically with 14. So it is really 14. The coordinates are 14. And it lines up right beside 8. 8. Okay. I'll put those numbers there because I want our calculations to reflect those numbers. Now, the thing is this. If you remember previously, we spoke about Pythagoras theorem, right? Or in books, websites, you probably would have done it before, where you calculate the length of what is called the hypotenuse of a right-angled triangle. You use what is called Pythagoras theorem. Let us draw a line going across from A. Draw this line. I'm trying to make it straight. I'm using freehand here. All right. Or let me not bother to do that. It's too wavy and lean. Let me see if I can get a straight line, a proper straight line from here to here. Okay, I have a straight line. Another proper straight line from up here to down here. Good. So these are the sides of the right angle triangle, and we can see that we have our right angle right here, and the symbol for right angle, we can just put it right there. Good. Now, what Pythagoras theorem says is that the hypotenuse, the square on the hypotenuse, let's call it h squared, which is our original line, equals the square of one side, the square on one side. How long is this? It goes 1, 2, 3, 4, 5, 6 long. So it is 6 squared plus the square on the other side. How long is this side? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 long. It's 14 squared. Alright? So 8 squared is 6 squared plus 14 squared. So this is 6 squared. 8 squared is 36 plus 14 squared. What's 14 squared again? Let me use my calculator here. So I have my 14 squared gives me 196. Ah, good. That's 196. So that's 196. So 8 squared equals, we're going to have our 196 plus our 36, 6 and 6 is 12, bring down the 2, carry 1, 9 and 1 is 10 and 3, 13, bring down the 3, carry 1, 1 and 1 is 2, 232. 232 when we add them. Now, this is 8 squared. What we want is h. H is the hypotenuse and it's the length of our line here. The length of our hypotenuse is going to be the square root of 232. What's the square root of 232? Let's go back to our calculator. So we want to find the square root of 232. So the square root of 232 is 15.23. Call it 15.23. So the length of our line here is 15.23 units. If these were centimeters, we'd say centimeters. So we use Pythagoras theorem to do the calculation. Right? Now, let's put our coordinates in it, in the calculation, and see if we can come up with a formula for doing it. Here now, this height and this length are what we're going to look at. The length here is this was x1, and this line up with our x2. The difference between x1 and x2, so we have x2 minus x1. That's the length of this side of the triangle. What's the length of this side of the triangle? This lines up with, this is 8, let me write the 8 up here. And this is 2, lines up with 2, the 2 is right here. So this height now between the 8 and 2, this 8 lines up with our y2. So this is y2. And this 2 lines up with our y1. This is y1. And we saw it here. Y1 is 2 and y2 is 8. So this height is the difference between y2 and y1. So it is y2 minus y1. Now what we did earlier, let's put these in brackets. What we did earlier was to calculate the hypotenuse square as being this length square plus this length square. So the length of the line, L squared, the length squared, let me rub out some, erase some of these things. I don't want to crowd the board too much. This length squared is, let me put it up here, because this is the line that we're calculating. The length of this line squared equal this length squared, which is really x2 minus x1 squared, plus this length squared, which is y2 minus y1 squared. But then when we're going to find L alone instead of L squared, what we want is just L alone. What we have is L is the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is the formula we have. Alright? The thing is, you could also use the formula the square root of, if you want to put the x1 first, x1 minus x2 squared plus y1 minus y2 squared. Alright? And that's the formula that you use to calculate the length of a straight line. Some of these formulas might be given on your formula sheet, but the thing is, when you actually are able to see where the formula comes from, then you're better able to understand the question in its entirety, right? You're better able to understand and remember how to do the question when you actually understand where these formulas and so on originate. Alright, so this is the length of a line, the formula for the length of a line. So let me just write down one nice formula here. So the formula for the length of this line is, length of a straight line is, length is the square root of x1 minus x2 squared plus y1 minus y2 squared. That's the formula to calculate the length of a straight line.